this issue of Spacecraft Guide, we are going back into the Orion spacecraft, and we're going to work on the instrument that tells the up from down. And for this one, we have a special thing we'd like to thank some people. Mark Kirkman, who had first experience with the primary flight display, Dave Bowman for finding the documents on the PDF or PFD, the primary flight display, and Felicia Vreeland and her Facebook page, The Space Report. So what we're going to do is we're going to look, there's Munikin there, we are going to go to the control panel, and when you click on it, it takes you to the control panel, and you can see here we're going to focus on this section right here. I had to break it down a little bit more. So when you click on it, it takes you to the primary flight display. So these are all the instruments that the astronaut needs when flying a NASA spacecraft. And if we're going to focus on this section here, which is the local vertical local horizon. And you can see that right here. Now, what the vertical local horizon is, it consists of spacecraft attitude indicators, attitude errors, bank angle cues. The attitude director indicator, ADI ball, provides a 3D representation of the spacecraft attitude with a local vertical and local horizon reference frame. So what that means is, when you're in space, which way is up? Well, you don't know. So you have a local horizon. That's the horizon that you choose, and you reference that for whatever you want. Now, we're going to go one step further. We're going to go into the attitude display indicator. Now, we did this on the Starliner, so we just have a little bit more information. So this provides a 3D representation of the spacecraft attitude with a local vertical horizon reference frame. Again, your horizon, your vertical. These attitudes are provided as Euler angles. Okay, we're going to go a little bit into Euler angles here, but those are basically the X, Y, and Z axes, and your difference between your angle and the reference that you're using. Now that is converted within the entry display feeder from a direction cosine matrix using pitch, yaw, and roll under the Euler sequence. Okay, so now when we go into general, this is going to be the actual document that I got all this information from, and thank Dave Bowler for finding this document, along with a couple other people who also showed that to me. But okay, the primary flight display, and we are here. It says because the crew is flying backwards throughout. Okay, so this is actually when they're entering back into the atmosphere. It says because the crew is flying backwards through the atmosphere, the footprint is oriented upside down. South is on the top, north is on the bottom. And that is the beauty of using this primary flight display, because it'll give you your local reference as you're flying. And this way, you're flying backwards. And we've talked about that before. So this is the entry primary flight display. So this is your flying backwards. And you can see this is standard for NASA. Sorry about that. So that is what we are talking about with the display, the ADI, or the attitude directional indicator. Now, for those who are my Patreon subscribers, we're going to go into the schematic. So even if you're a free Patreon, well, actually, this is a special one. This is for my paying subscribers who are in the top tier, which are the into the future, because this is a future spacecraft. We're going to look into the schematic. So when you click on it, it takes you to the primary guidance and navigation section. Now I took this from this is the Apollo lunar lander because this is the only schematics I could find right now that does a good description of it. If you happen to have the schematics on how this works, I would highly appreciate it if you could hand it off to me so I could add that. But here we find the inertial measuring unit. Okay, so that is, we call that the stable platform, or that gyroscope that a lot of people use for, that used to use in the older airplanes. They upgraded it, and we're going to look at that a little bit later. And then here we have the gimbal errors and drives. The information comes down, and we have the gimbal angles, which are that Euler measurements that we talked about, and the gimbal angles also come here into the coupling data and 3 inertial channels. So part of that goes to the abort guidance system, the AGS, and then also to the flight display. You can see pitch, roll, and yaw error. So we see the unit itself, the inertial measurement unit, the information, the angles it's getting, going into the computer to figure out that matrix that we talked about, and then it coming out in at the display of the ball, with the blue being up and the brown or black being down. So now we're going to go a little bit deeper, and we're going to go into how that the platform, the stable platform, works. So we go to the IMU gimbal assembly diagram. You can see this are 3 separate gyroscopes, and you see here they have the X, Y, and Z axis. And the reason why they have the 3 is they put them 90 degrees to each other, and that actually keeps the platform even more stable, because if you, for a gyroscope, if you force it 90 degrees to that force is when it precesses. This, with the 3 gyroscopes being 90 degrees from each other, keeps it stable, and they keep it spinning. And we see the X, the Y, and the Z axes. So it all spins around this gyro, and this stays stable. You see the stable member, that does not move. The ship moves around it, and the computer figures out where that the ADI is positioned for you to look at. Again, local, local vertical, local horizontal. That is all based off of this, and those measurements they get, that's right in here. So those Euler numbers, those numbers are getting from this on the Z-axis, on this rotation here on the X, and this on the Y. And you can see they have the torque monitor duplex ball bearing slip ring. Okay, so, and then has contacts on it. So that's how they're measuring all of those movements. And from those movements, we get this display in the spacecraft. So I hope you like this this description here. Again, this is only for our special members, and we want to thank all of you for supporting me on that. I really do appreciate it. And if you'd like to see more, please convince your friends to join us. And hopefully, as we get more and more people, we'll get more and more resources, and we'll be able to get more and more explanations like this, and more people to help me find the information. And again, I thank you.